Okay, so you're starting with 100% of your bacteria. Will you add or subtract 20%? You are going to subtract because you're decreasing. Oh, I can't spell today. Let's do that again. You're going to subtract because you're decreasing. So to find 20% of 1,000, you're multiplying 1,000 times 0.20, you get 200. 1,000 minus 800 minus 200 is 800 bacteria. And then part C, to find the number of bacteria after 2 months, you're doing 20% of 800. So 800 times 20% gives me 160 bacteria. So if I do 800 minus 160, that gives me 640 bacteria. And then I'm going to do the same process for part C. So 640 times 20%. Let me get my calculator out. 640 times 20% is 128. And if I do 640 minus 128, that's going to give me 512. So I have 512 after 3 months. So this is a two-step process. So on the next screen, we're going to basically do it in one step. We kind of did this in 03 or 0222. So we'll do that on the next screen. So if you subtract 20% of the previous row, what percent remains in the next row? So if you remember, they talked about you started off with, ooh, I didn't mean to do that. So if you start off with 100% at the beginning and you're decreasing it by 20%, you have 80% remaining on each row. So that means to get to the next row, you're going to multiply by 0.80 each time. So I'm going to multiply by 0.80 each time. So this is my common ratio. So I'm going to multiply 1,000 times 0.80. So if I do that, I'm going to get 800. And then if I do 800 times 0.80, so 800 times 0.80 on my handy dandy calculator, I'm going to get 640. And then if I do 640 times 0.80, 640 times 0.80 on my handy dandy calculator, I'm going to get 512. And it says complete the table again, but this time multiply by the previous row you found in the decimal in part E. And you should notice that these are the same numbers that you got on the previous one. So it's a lot easier to multiply by that number rather than do that two-step process. Okay. There are 3,000 bacteria. Initially, there are 3,000 bacteria. That amount decreases by 24% each week. So if you're decreasing by 24%, we're starting off with 100% and you're subtracting 24%. So if I do 100 minus 24, that means you've got 76% remaining each week. So we're going to multiply by 0.76 each time. So if I start with 3,000 and I multiply by 0.76, so 3,000 times 0.76, that is going to give me 2280. Okay, and then let me do this again. So 2280 times 0.76, that's going to give me, oops, so now times 0.76 again, that's going to give me 17. And since we're dealing with a number of bacteria, I'm going to round it to a whole number. That gives me 1732.8, but I'm going to round it to a whole number because we're dealing with bacteria. So that's going to give me 1733. So now if I do 1733 times 0.76, that's going to give me, so 1733 times 0.76, that's going to give me 1317.08. So about 17, oops, sorry, 13, 1317. So, and then round that to 1317. And then the purple one, we rounded that one to, 1733. So if it's bacteria, you can't have a partial bacteria, so I'd round that to whole numbers. Okay, there are 2,000 bacteria, and that amount increases by 40% each month. So if you are increasing, if you start with 100%, you're going to basically add. Okay, so it says find the number of bacteria after 1 month. So I want to find 40% of 2,000. So if I do 2,000 times 0.40, that's going to give me 800. So if I do 2,000 plus 800, that's going to give me 2,800 bacteria. So we're going to fill that into my table to the right. Find the number of bacteria after 2 months. So then if I do 2,800 times 40%, let me get my calculator out. 2,800 times 0.40, that's going to give me, 2,800 times 0.40, that gives me 1,120. So that's another 1,120 that I'm going to add on top of that. So 2,800 plus 1,120 takes me to 3,920. And then for part C, I'm going to do the same thing. 3,920 times 0.40. Let me change my pen color again. So that's another 1,568. So then 3,920 plus 1,568 gives me 5,488. So that's 5,488. So that's the long way to do that. So you basically multiply by 0.40 and then add that additional part onto it. So then they want us to let me find a different color. No, I don't like those colors. I'm trying to find an orange pen. That's not orange. Okay, never mind. I'll stick with these. Okay. Then it says if you add 40% to the previous row, then what is the total in the next row? So just like the other one, if I start off, if I start off with 100% and I add 40%, I'm going to get 140%. And then if I move that decimal over, you're adding or you're multiplying by 1.40. So I'm going to multiply by 1.40 each time. So if I multiply by 1.40, so if I do 2,000 times 1.40, I'm going to get 2,800. And then I'll do 2,800 times 1.40. Oops. Okay. Let me go back and fix that. I didn't write that down right. Hold on, let me fix that. Hold on. 1.40. 1.40. Okay. And then 2,800 times 1.40 is going to give me 3,920. And then do 3,920 times 1.40. And then 3,920 times 1.40 is going to give me 5,488. And you'll notice they match. So they should give you the same thing. Okay. So we have 5,000 bacteria initially. The amount increases by 15% each day. So that means I'm doing 100% plus 15%, which means I'm doing 115%, which is 1.15. So I'm going to start with multiplying 5,000 times 1.15. So you're multiplying by 1.15 every time. And so I'm going to do 5,000 times 1.15. That's going to give me 5,750. Okay. So, 5,000 times 1.15 gives me 5,000 times 1.15 gives me 5,750. And then if I multiply by 1.15 again, I'm going to get, you get 6612.5. However, you're going to round that to 6613. So round that because you want a whole number. And then you're going to multiply that times 1.15. So 6613 times 1.15. And you're going to get 7604.95. Or you could leave it to the 6 point. And even if you left it the 66.12. And so I'm going to say, so that's about 76.05 or 04. So either way, so you got about 7605. Okay, Kim and Sabrina are both saving money for next semester's tuition. They both start with $5. So they're both starting off with $5 in the account. Kim saves $80 per week. So she saves $80 per week. I'm basically going to add $80 each week, which means, so I'm starting off with 5. I'm adding 85. 5 plus 80 is going to give me 85. Plus another 80 is going to give me 165. Plus another 80 is going to give me 245. Plus another 80 is going to give me 325. So that's what it means when she saves $80 per week. Sabrina puts in enough money to double the total from the week before. So I'm going to double it. So 5 times, so I'm going to double it. This gives me 10. If I double 10, I get 20. If I double 20, I get 40. If I double 40, I get 80. Okay. So that's basically, so this one is basically doubling. Double every week. Okay. So they're basically looking for you to start talking about, this is basically a linear pattern because you're adding every week. And this is an exponential pattern. So basically when you add or subtract every week, that's linear. And when you multiply or divide, that's exponential. Okay, maybe I jumped the gun a little bit, but it says one of the plans follows a linear pattern of growth. Which one? And so Kim's plan. So Kim's plan is linear because she adds $80 every week. Oops. Because she adds $80 every week. So you're adding, for a linear pattern, you're basically adding the same thing every week. That's what you're doing. You have a constant amount that you're adding every week. The other plan follows a pattern, but it's not linear. Describe the pattern, including units, which operation, add or multiply, you use to get one output from the other. And so Sabrina's plan is exponential because she doubled her money every week she multiplied to get the output value. So that one's exponential. Okay. The table at the right shows Garrison's bank account balance. Exponential change occurs when the output value is increased by the same factor. Okay. Factor meaning you multiplied or divided by something which is multiplied, called a common ratio. Recall how to find a common ratio. We start with the entry below, and we start with the entry below and divide by the previous one. So a common ratio in this example is, so if we look at this one and we do 40 divided by 80, so 40 divided by 80 is 1/2, and that's 0.5. So we can interpret the common ratio, the account value, and this is going from 80 to 40 to 20 to 10 to 5. It decreases by multiplying by 1/2 each week. So basically they're cutting the amount in their account by half each week. They're taking out half the amount of money in their account each week. Okay, on number 3, it says culture bacteria started with a size of 200, increased by 10% per day. So our common ratio, so if you're increasing by 10% per day, your ratio is going to be 1.10. Oops, not percent. The ratio is going to be 1.10 because you're basically taking the percent, you're doing your 100%, and you're adding on the 10%. So you're getting bigger or lower. So we can interpret your common ratio, and it's increasing multiplying by 1.10 each day. Oops. Complete the table, round to the nearest whole number. And so if you multiply by 1.10 each day, you're going to get 200, 220, 242, 266, 293. Basically, that's just whole plug and chug. Okay, so this is just a kind of summary of the last couple slides to complete the following. So this is just kind of talking about exponential stuff we've just gone over. So a common ratio of 1.25. So basically anything that's over 1, just kind of look at the decimal that's above 1. So a 1.25 is the same thing as a 25% increase. So if it's over 1, just look at the decimal past 1. It's a 25% increase. A common ratio of blank is the same as a 62% increase. So a 62% increase would be a 1.62. A common ratio of 2 is the same thing as a 100% increase, because a 1 basically means 100%. So a 2 would mean 200%. So a 2 is just a 100% increase. So exponential increase has a common ratio greater than 1. Okay, so now let's do the other way where we're doing decreases. So the value of a smartphone at 650 decreases 10% per month. So now you're doing 100% minus 10%. So that's going to give me 90%. So a common ratio, and this is an example of 0.90. We can interpret this: the value of the phone decreases by multiplying by 0.90 each month. So I'm going to multiply, round to the nearest dollar. So if I multiply, I'm going to start with 650. We're going to multiply by 0.90. So 650 times 0.90 is 585. 585 times 0.90 is 527. So 527 times 0.90 is 474. So you're multiplying by 0.90 each time. And then 474 times 0.90 is about 426 or 427. Depending on what you get on that. So round to the nearest dollar. 426, 427, depending on how you use the equation. So depending on how you round, 426, 427. Because if you use the equation, you're going to get 426. If you round, you're going to get 427. Okay, so here is the same kind of summary thing. So a common ratio of 0.2 is the same as a blank decrease. So keep in mind, if you have a 0.2, so a whole number 1 means 100%. So a 0.2, basically that is a 20%. So that is an 80% decrease. So keep that in mind. So a 40% decrease basically is a common ratio of a 0.60. And then a common ratio of 0.13. So a 0.13 down here means that you've gone down 87%. So keep in mind your decreases, these two are not the same except for 50%. Okay. So these numbers should add up to 100%. So your exponential decrease has a common ratio between 0 and 1. Okay, your graph shows your number of available seats at Austin Community College in the weeks after registration open. Does the graph more closely represent a linear or exponential rate of change? Explain your answer. So if I look at the picture, the one way you can tell is if this is curved, it's exponential. If it's a straight line, it's linear. So this is exponential. Okay, let's do this again. I'm trying to write on a vertical screen, so let's do this again. This is exponential. The graph is curved. Okay, so create a table of values from the graph. So if it's curved, okay, mainly you need to do graphs, or you need to have points that are next to each other. So 0 looks like 40. 1, I'm going to say looks like 32. 2 looks like 26. 3 looks like 21. 4 looks like 17. 5, I'm going to say looks like 13. So determine and interpret the common ratio and give the percent increase or decrease. Be sure your answers are in complete sentence. So I'm just going to do, since I don't have enough room on here, I'm just going to find the common ratio. So let's do, let me change colors. So let's try this. So 32 divided by 40. Let me do this. So 32 divided by 40, that's 0.8. Remember, these are not always going to be exact because we're estimating. 26 divided by 32, 26 divided by 32, that's 0.8125. 21 over 26, 21 divided by 26 is 0.8077. 17 divided by 21, that's 0.8095. 13 divided by 17. That's 0.7647. So probably I didn't do a good job of estimating that one the best, because these are closer together, like 0.80. This one probably wasn't the best. So if I look at all of them, and I'll try to write my sentence over here. So my number of seats, I'm just going to write on top of, hold on. I'm just going to write on top of the graph. So my number of seats, so the number of seats, and you can tell this is decreasing, decreases by multiplying, I can't spell multiplying, by multiplying by, I'm going to say this is about 0.80, by 0.80 each week of registration. So that's my sentence describing my graph. Okay, a new restaurant opened and the owner kept track of the number of customers per week. Find the ratio between each output and input, between the output and the one before it. Is the ratio approximately the same for the weeks, for all the weeks shown? So we'll do 320 over 250. Oh, let me not do it sideways. Let's try this again. Okay, so let me do this again. Okay, so let me try this again. 320 over 250 is going to give me about 1.28. 419 over 320. 419 over 320 gives me about 1.31. 532 over 419 gives me 1.27. 692 over 532 gives me 1.30. Let me find another color. And then, 886 over 692 gives me 1.28. So if you look at all of them, I'm going to say, let me pick another color that I haven't used, that they're all approximately about 1.3. They're not all the same. So if I want to interpret these, so interpret the common ratio and give the percent increase or decrease. So the number of customers increases because it's getting bigger, increases by multiplying, multiplying by 1.3 each week. And then it says give the percent increase or decrease. And so the number of customers so if it's a 0.3, that's a 30% increase. Customers increases 30% each week. Okay. I'm going to try something. I don't know if it's going to work. I don't think it's going to let me do it. No. Dang it, it's not going to let me do it. Okay. Says, do you think you could use an exponential model to make predictions about the number of customers at the restaurant after 7 weeks? So I may not be able to write it on here, but I'm just going to say it so you can just listen. So now after 7 weeks, I would say yes, because with exponential, it could probably hold it. But after, so probably yes after 7 weeks. But if I do after a year, y'all don't know how to write the equation yet. But after a year, you would have millions and millions of customers. So it probably is not going to hold it after a year. So I'm not going to write the answer down here because I don't have enough room. But after 7 weeks, yes, it probably can hold the number of customers. But if I were to give you the equation, which we'll learn in a couple lessons, but you don't know how to do it yet. But after a year, it's somewhere in the millions of customers. And so no, this model will not hold after a year. But after 7 weeks, yes, but no, not after a year. So I wouldn't worry about this one for right now, but everything else, you're good.